Hello students, in this video we'll discuss the cross product of two vectors. If we're given two vectors v, which we're going to write as v1, v2, v3, and w, which we'll write as w1, w2, w3, then we define v cross w as the determinant of I, j, k, v1, v2, v3, w1, w2, w3. And if we expand out this determinant, what we'll get is the following. We'll get a v2, w3 minus w2, v3. And recall what we do is to do the I component or the x component, we punch out the row and column in which I resides, and we were left with this 2 by 2 subdeterminant, and we compute the 2 by 2 subdeterminant to get the coefficient of I. So this is my first entry is my I component. The j component will be what I get when I do the determinant of v1, w3, and then w1, v3 with a negative sign. So that's going to be a w1, v3 minus w3, v1. And finally, the k entry will be v1, w2 minus v2, w1. And so this formula over here looks a little bit complicated, but as long as you remember this determinant formulation, it becomes straightforward. So let's see an example of doing this. So here's an example. Let's find 1, 0, 1 cross negative 1, 1, 0. So what we'll do is we'll use this definition. This will be the determinant of I hat, j hat, k hat, and then 1, 0, 1, and then negative 1, 1, 0. And so if we're going to compute this, let's do this. So the I entry will be what? So the I entry will be the determinant of that submatrix right over here of the 0, 1, 1, 0. So that's going to be a negative 1 I hat. The j entry is going to be, well, let's look at this to be a 1 and a 0, gives me 0, then a negative 1 times 1. And so that's going to be a positive 1, but the j entry is negative, so we'll get a negative 1 j hat. And the k hat entry will be this determinant over here, which would be 1, 0, negative 1, 1, and that's going to give me a 1 k hat. And so what we get over here is we get the vector that this cross product is equal to the vector negative 1, and then a 1. So we get negative 1, 1, 1. And an important property of these cross products is the following. If I take the first vector we started with, 1, 0, 1, and I dot it with the cross product, negative 1, 1, what we'll get is we'll get a 0. And if we take the second vector, negative 1, 1, 0, and dot it with our vector negative 1, 1, we'll also get 0. And this is true in general. The general result is that when we cross proposition, the vector v cross w is perpendicular to both v and w, and furthermore, and the length of v cross w is the length of v, the length of w, times the sine of the angle in between those vectors. So here theta is the angle between v and w. And as another consequence of this, well, we know that if we were to generate a parallelogram, so if we look at a parallelogram, if this is my vector over here v, and this is my vector over here w, I can draw another copy of w over here, and another copy of v over here. So in other words, two vectors v and w that are not in the same direction will generate a parallelogram. And the area of this parallelogram is the base times the height. Well, the base times the height is exactly equal to this quantity over here. And so the area of this parallelogram is exactly just the magnitude of the vector v cross the vector w. So this cross product of these two vectors gives you two things. It gives you a vector which is perpendicular to the two vectors you started with, v and w, and it's chosen in a way, it's defined in such a way that gives you the area, that its length of the cross product is the area of the parallelogram that is generated by vectors v and w. Thank you very much.